Okay, so today we're going to be talking about inverse trig functions. Okay, inverse trig functions. All right. And so let me see here if I can just introduce them to you here. So, for example, and we're going to inverse trig functions are used to solve for angles, okay, yeah, okay. So inverse trig functions are used to solve for angles. Okay, so we use these to solve for angles. Okay, after we're given a ratio or sides of a triangle. So either we're given a trig ratio or sides of a triangle. So it's kind of how we solve like very simple trig equations. I mean, for example here, let's say we've got something like this. Cosine of theta equals the square root of 3 over 2. Okay. How do we solve this? How do we solve this? And there's actually a couple different ways you can do it. Okay, I'm going to show you the non-calculator way first, and then I'll also show you the calculator way too. Okay. Okay. So believe it or not, we can actually figure this out without a calculator. Okay. Now this one is unique. That's what's the way. Okay. So the non-calculator way here. Okay. This one's unique. Okay. Not every one of these will we be able to solve without a calculator, right? And you've seen the numbers we run into, right? They're decimals a lot of times, and so I was like, well, how are we supposed to come up with those decimals in our, without a calculator and stuff like that? Okay. But for this one, we can actually solve without a calculator. Okay, and it has to do with the fact that this number, this root 3, and this 2, they are both sides in one of our special right triangles. Okay, now, specifically, it's the 30, 60, 90 right triangle. Okay, you remember that one? Okay, and a 30, 60, 90 right triangle. Okay, let's say this is the 60-degree angle and that's the 30-degree angle. Okay. You can make this any length of side you want, but I'll just make it a nice, easy. Okay. There's root 3, right? There's 2 right there, right? And so in this special right triangle here, the 30, 60, 90 right triangle, okay, which of these angles here, when you take the cosine of it, is going to give you root 3 over 2? Which one of these angles here, when you take the cosine of it, is going to give you root 3 over 2? Well, let's just check and see here, right? Let's guess that it's 60, right? What's cosine of 60 going to be? Well, cosine is, well, think about SOHCAHTOA again, right? Cosine is what over what? Adjacent to hypotenuse. What's the adjacent leg to 60 degrees? It's what? What's the adjacent leg here? What measure? That's not the adjacent leg. That's hypotenuse. Be careful. It's 1, right? It's 1. Okay, 1. All right, and what's the hypotenuse then of this triangle? 2. So the cosine of 60 is 1 over 2. That's not what we want. We want cosine of our angle to be root 3 over 2. So let's try the 30-degree angle. What's the adjacent leg to 30 degrees? Root 3, right? And what's the hypotenuse? 2. So cosine of 30 degrees, right? Cosine of 30 degrees equals the square root of 3 over 2. So in other words, theta equals 30 degrees there. Okay? The answer is 30 degrees. The answer is 30 degrees. All right. Okay. That's one way to do it.
And why is it 30 degrees?
Because in our 30, 60, 90 right triangle here, okay, if you take the cosine of 30 degrees, right, so cosine of 30, right, cosine of 30 is going to be the adjacent leg, which is root 3, over the hypotenuse of 2. Right? So that's why 30 degrees is our answer there, because when you plug 30 degrees, when you take the cosine of 30, you get root 3 over 2. So that's the answer. Okay. How else can we solve it? Well, there's also a way with a calculator too. Okay, so I'll show you with the calculator way here. Okay. With the calculator, what you're going to do is, again, we'll start with the cosine of theta equals root 3 over 2. Okay. And what we're going to do is, I mean, honestly, right, or obviously here, basically here, we want to solve for theta. We want theta by itself. But what's with the theta here that's kind of stopping us, right? What's with the theta here that we need to get rid of in this equation, this little equation right here? What's with the theta? Cosine, right? Cosine, okay? To get rid of cosine is, how do we get rid of cosine? What cancels out cosine? Well, I can't divide both sides by cosine. This is not cosine times theta. It's cosine of theta. Okay. This is like back when we had natural logs or just logarithms in general. Okay. We couldn't just like divide both sides by a log. We had to eliminate the logarithm. We needed something that cancels it out. So we are going to use the inverse of cosine, and the inverse of cosine is cosine inverse, just like that. And we're going to take the cosine inverse of the left-hand side. And we're also going to take cosine inverse of the right-hand side. And actually, you know what? I should probably, whatever. We'll just squeeze it in right back. So really, this is what it should look like. Cosine inverse of the cosine of theta equals cosine inverse of the square root of 3 over 2. Okay? So the cosine inverse and cosine are going to exactly cancel and leave us with just theta there. And then how do we evaluate cosine inverse of root 3 over 2? Well, that's where we go to our graphing calculators here. Okay. Now, do you guys see where on your calculators you're going to get cosine inverse? Second cosine, exactly right. You can see it right there. Second cosine, right there, then blue for me. Second cosine, and there it is, cosine inverse. I'm going to type in, off the screen, there we go. I'll type in root 3 over 2. So second square root of 3, divide by 2. Okay, make sure the divide by 2 is outside of the square root. Those of you who have like the pretty type like I do. And you get 30. But it's really 30 what? Since we're talking about theta, that's an angle. It's 30 degrees. That's right. Okay, so there's our answer that way too. Okay, without having to worry about our special right triangles or anything like that. Okay. All right, so let's try another one here. Let's try, okay, let's solve for theta here. Excuse me. And let's do let's do root 2 over 2. So let's do sine of theta equals root 2 over 2. Sine of theta equals root 2 over 2. Okay. Well, again, okay, we can actually do this. We can do this one without a calculator. Okay, if we refer back to our special right triangle, the other special right triangle, the 45, 45, 90. Okay, like that. Excuse me. Okay, and then this one is. Make sure I get this right here. This is one way to set up the special right triangle here, using these kind of sides. Okay, so you can say root 2, and then 2. Okay. As you can see here, we see the root 2, we see the 2, right? So sine of what angle here? Sine of which angle in this special right triangle is going to give us root 2 over 2? Sine of which angle here in that special right triangle? And the 45, 45, 90. Well, let's just check here, right? So let's look here. Let's pick this angle, 45 degrees, okay? If we do sine of 45 degrees, sine is opposite. What's opposite 45 degrees? Root 2, right? Okay. And what's h? And it's over the hypotenuse, right? So over the hypotenuse, what is the hypotenuse of this right triangle? 2. So it becomes root 2 over 2. So sine of 45 equals root 2 over 2. So the theta here has got to be 45 degrees. Theta's got to be 45. Okay, but of course we can use our calculators too. Okay. We'll take sine inverse. Actually, I'm going to just do it down here. We'll do sine inverse of the left-hand side. Okay, and that's equal to sine inverse of the right-hand side. Okay. We can just type into our calculators. Second sine this time, right? Second sine. Let me see if I can get this to fit. There you go, something like that. Second sine of root 2 over 2. Again, make sure that O over 2 is not inside the square root there. And you get, there you go, 45. 45 degrees that way. And again, that sine inverse and the sine cancel out. You're left with just theta. Now, the other thing here, right, is what if we didn't want this theta in degrees? What if we wanted it in radians? Well, it's very easy to do in the calculator. All you got to do is just press the mode button. Again, the mode button is right next to the delete, and this between delete and second. Press the mode button, okay, and just change your mode from degrees to radians. Okay, and then when I type in sine inverse of root 2 over 2, I get this, 0.785, okay, which is the same thing as pi over 4. Okay, right, because 45 degrees is the same thing as pi over 4. All right, and if you were to convert the 45 degrees to radians, it'd be pi over 4, and so it just gives you the radian measure there. Okay, and you're fine to just like round that, maybe like 3 decimal places or something like that. Okay, so that's the easy way to kind of get it in degrees and in radians, right? We just change the mode in our calculator, and then I would typically make sure that you're back in degrees, because typically we're working in degrees for the most part here, but you can use radians too. Okay, so that's how we can solve some of those little easier things here. All right, so let me see here. How about here? I'll give you guys one to try. So how about you guys try, and you guys can feel free to just use your calculator if you want to. Okay. I'll give you 2. Let's do tangent of theta is equal to 1. And let's do cosine of theta equals 1/2. Okay. And let's give theta in degrees and radians. Give theta in degrees and radians there. Okay. And again, you can use your calculator if you want to. Feel free to use your calculator if you want. It does, right? So you want to use the triangle. So you want to use, if you're trying to do it without a calculator, is that what you're trying to do? If you want to use the triangle that gives you that ratio. So for example here, right? Remember 2, cosine of theta equals 1/2. There's no way in this 45, 45, 90 triangle for me to get 1/2, right? Because I don't have any 1. I have a 2, but I don't have any 1s here to kind of like put that in the right ratio. However, in the 30, 60, 90, let's scoot this up. In the 30, 60, 90, right, we do have a 1 and a 2. So yeah, you could use, I would say you want to use that triangle then for the cosine of theta equals 1/2. All right, and then for the first one, Mike, right, if you're trying to get a your tangent of your angle to be 1, okay, well there's no way for us to get a ratio of 1 here because it's going to be 2 over 1 or 1 over 2 or 2 over root 3 or root 3 over 2 or root 3 over 1 or 1 over root 3, right? So there's no way to get a 1 there because I can't get the same number. But here it's possible to get a 1 if I do root 2 over root 2, right? That would give me a 1. And so you can actually, yeah, you can use your, so that's how you kind of like look at your special right triangles that you've got and then decide what the angles are based on, or decide what ratio you're shooting for there to help you know which triangle you want to use. Okay, but ultimately you can also just type in your calculator too. Your calculator died? Oh, calculator question. Gotcha. So yeah, you are in radian mode right now. So you press the mode button. And then go down to, see on this radian mode, have a degree and enter. Now, you go back to your home screen and type in the same thing you just typed in. Voila. So that was the radian measure. That's your equivalent degree measure there. Okay. Okay. So what answers do we have here? What is, number 1, that theta going to be? Tangent theta equals 1, so that means theta must be 45 degrees. Okay, or what in radians? And we get the decimal there for the radians? Like 0.785, which is exactly actually pi over 4. Okay, if we were to convert that like more precisely, 45 degrees is pi over 4. Okay, and again, that's all you got to do is just go second tangent, okay, 45 degrees, or wait, no, second tangent 1, my bad. There's the 45 degrees. Okay. Then I'll press the mode button and change my mode to radians. And then when I type in tangent inverse of 1 again, there's the radian measure right there, 0.785. Okay. How about cosine of a half? What angle theta? 60. Okay. Excuse me. Cosine of theta is equal to half 60 degrees. That's good. Or mode radian cosine inverse of 0.5, 1/2, or 1.047. Okay, as radians, which is really pi over 3. It's really pi over 3. All right. So now, why do we bother talking about these, okay, coming up with these crazy numbers and stuff like that? Well, it's helpful because we can use it in our solving of right triangles. So for example here, okay, let's say we want to, again, we're going to find angle theta. Yep. Okay. And let's now set up a right triangle here. Well, we want to find angle theta. So that's supposed to be a 9 there. So what trig ratio do we want to use to relate all these pieces of information? We have an angle. We have this side 4 and the hypotenuse of 9 there. So what trig ratio would be a good choice to use here? No idea. Okay. Well, what side? So let's think about what these sides are. So 4 is right next to theta, which means it's adjacent, opposite, or hypotenuse. It's the, okay, yeah, so right, okay, yeah. So we have the adjacent side here, yep, and we also have the hypotenuse. We do not have the opposite side. So we don't want to use any trig ratio, so not sine and not tangent, because we don't have the opposite side here. So cosine, right. Now, cosine of theta equals adjacent 4 over hypotenuse 9. Now let's say we wanted to be stubborn though, and we really did want to use sine or tangent. What could we do here to figure out the opposite leg? Pythagorean theorem, right. We could use Pythagorean theorem here to find this opposite leg, and then use sine or tangent, okay? So it's not like we're stuck using only cosine here. If you really wanted to, you could use tangent or sine, okay? But you have to use Pythagorean theorem first, and then solve. Why not just go ahead and just do this? It's so much easier, right? Just ready to go. Okay? So to get theta then, what do you need to do to both sides? To get theta, what should we do to both sides? How do you undo cosine? We're going to use cosine inverse. Cosine inverse. Yeah, cosine negative 1. So we get theta equals, and then cosine inverse of 4/9. Second, cosine 4 over 9. Oops, I think I'm in radian mode. Let me change it back to degrees here again. Okay, 63.6 we'll say degrees. 63.6 degrees. Okay. All right, one more here. A monster truck drives off a ramp to jump some cars. The ramp has a height of 8 feet and a horizontal length of 20 feet. What is the angle theta of the ramp? Okay, so go ahead and draw the picture for this. I want you to go ahead and try and draw the picture for this. Okay, just try and draw the picture. You don't have to draw the monster truck, just the ramp, right? Really, we're trying to solve for the ramp there, right? So the ramp has a height of 8 feet and a horizontal length of 20 feet. What is the angle theta of the ramp? So go ahead, draw the ramp with a height of 8 feet, horizontal length of 20 feet, and then put the theta in where you think it should go, right? What is the angle theta of the ramp? Okay. Put theta in where you think it should go. All right, so draw a picture and put in the angle theta where you think it should go. Because it's important, right, in situations like this that we can, you know, put them in the right spot. Right, and while you're doing that, I'll go ahead and scan some work. No set today. We will have sets tomorrow, I think. Should have set tomorrow. Okay, so a ramp, right? It's going to look something like this. Right angle there. Okay. The height is 8 feet. Hopefully that was easy enough for you guys to kind of recognize. Okay, height 8 feet there, right? Now the horizontal length. Horizontal length, is that going to be this other leg or is it going to be the hypotenuse? What do you think? Should the 20 be for the hypotenuse or for this other leg here? The leg, right? Because we're talking horizontal, so that's just this, not like kind of the, you know, not the not that diagonal height there. The length of. So how would this be described? You might say like the length of the ramp or something like that. The length of the ramp might be, you know, if you put it there. All right. Now, where should the theta go? Should the theta be on the ground or up here at the top? Should theta be down here or up at the top? Yeah, so it's actually going to be down here. There's your theta. Okay. So what trig ratio can we use to relate all three of these pieces of information? Which trig ratio here are we going to use? Sine, cosine, or tangent? Tangent, why? Okay, yeah, we have an opposite leg, the 8. We have the adjacent leg, 20, okay? We don't have the hypotenuse. Again, we could find the hypotenuse using Pythagorean theorem, and then you could use sine, cosine, or tangent. But since we have the opposite leg and the adjacent leg, let's use tangent of theta, and that's going to equal 8 over 20. Okay? And then we'll use tangent inverse of both sides. Okay, so those will cancel. We're left with just theta there. And then in my calculator, I'll just type in second tangent, 8 divided by 20. And I get 21.8. And that'll be in degrees. Okay? So that's the approximate measure of the ramp there. So we'll stop there. All right, on page, let's see here, 878. So this is in the green book again. So there's a scan in Google Classroom, page 878. I'll upload here in just a second. Okay, I'm going to have you do. Let's see here. 7 to 10. The directions for 7 to 10 say don't use a calculator. You may use a calculator. Okay, don't worry about that. You may use a calculator there. Okay. Then 27 and 28. Okay, so 6 problems there. All right, 6 problems there for you. Okay, we'll just do that. Okay, let me get it posted here real quick so you can get started if you want. Yes, go ahead.